Ma'am, you're on mute.
Can you hear me now?
Yes, ma'am.
Okay, I'm so sorry. Like my internet connection got disconnected. I'm sorry for the. Okay, let's get started with the class. Okay, before that, any doubts from the previous session? If you have doubts, ask me before we move on to the next topic. Anyone? You have any doubts? Did you people practice?
Yes, ma'am.
Okay, fine. Karan, then Mohammed, your videos, guys. Please don't turn off your videos, okay? To keep telling you guys again and again. Okay, fine then. Let's start. I'll share the screen. Okay, you guys can see the white screen?
Yes, ma'am.
Just a second. Fine. The topic for today will be fundamental theorem of arithmetic. Okay. What is this fundamental theorem of arithmetic? Any idea? Yes. Okay. You guys, okay, you people have attended foundation class, right?
Yes, ma'am.
Yes. So in the foundation class, do you guys remember we have learned about factorization? And
Yes, ma'am.
from that we did prime factorization. Do you guys remember?
Yes, ma'am.
And what is prime factorization?
Factorization done by only prime number.
Yes. So you factorize any given natural number and you factorize it using only the prime numbers. That's prime factorization, correct? So in this fundamental theorem of arithmetic, it's nothing but you take up any natural number, correct? So that natural number can be expressed in terms of the product of prime factors. Okay? So it can be any natural number. Okay. So let's take an example. Let's say if I take up 6. 6, I can factorize it as
2 into 3.
2 into 3. So 2 is also a prime number. 3 is also a prime number. Correct? Let's say, yeah. Let's take an example. 24. How do you factorize this number? And you have to use only the prime factors.
2 into 2 into 2 into 3.
Like if you don't know how do you get this factors, either you can go for like factor tree method or the long division. So I'll show you both the methods. Long division method is how you do it for HCF and LCM. 24, 2 2s are, sorry, 2 12s are, 2 3 is 3 1. You do it until you get a 1. And the factor tree method is we have a 24 here. This is called as the root number. Okay. And you split it in terms of, let's say, 12 to the 24. Right? Then 2 is a prime number. So that's the end there. Then 12 we can factorize it further. 6 2s are 12. So 6 and 2 are the factors. And again 2 is done. We factorize 6 again. 2 3s are 6. So whatever the last numbers you have got, these numbers, those are the prime factors. Understood? So I've got mainly two methods, long division and the factorial method. And you can choose like whichever you feel easy, you can choose that method. Okay? Any doubts with both the methods, long division and the factorial method? Want me to explain again?
No, ma'am.
No, ma'am.
Sure. Arpita, Inshara, Mohammed,
No, ma'am.
Ruti. Mohammed, I can't see you. Rajwan.
My video.
No, ma'am. No, no.
Okay. Fine. So next, I'll just give you like a few like numbers. Just try to factorize them. Okay. Did you people write this? Shall I erase this?
Yes,
Shrikar,
ma'am.
done?
Yes,
Yes,
ma'am.
ma'am. You can.
Yes, ma'am. Done.
Okay. Dhruti, are you writing?
No, ma'am.
Why?
Ma'am, already I wrote it, ma'am.
Did you finish writing it?
Yes, ma'am.
Okay, fine then. Okay, try this. Yeah. Everyone has to do it, and only the one will answer which I ask. Okay. I'll just ask some random, take some random name, and only that person will answer. Everyone has to do it.
Done, ma'am.
Great. Dhruti, can you tell me the answer? Expansion.
Ma'am, me.
Dhruti. Dhruti, are you done? Did you finish? Dhruti, are you there? Pawan?
Ma'am, 1 second. ma'am.
Fast, Pawan. long? I've given you enough time.
Ma'am,
Yes, tell me.
ma'am, can we divide it by 17?
You have to tell me, Pawan. Can
Ma'am,
you?
because I divided by. Ma'am, I got different answer.
Arpita?
Yes, ma'am.
Yeah.
Can we divide by 3?
Can you divide it by 3? You tell me.
No, ma'am, I did not get.
You didn't get the answer. Okay,
No,
just
ma'am.
check. Fine, we'll check it. Okay,
3 5s are 15.
5s are 15. Okay, 2. Get the 7. 2 9s are
3 9s are 27.
and you have this one here,
One.
one reminder. So this 1171 doesn't go with 3. Okay. What's the
Yes,
next
ma'am.
number after 3? Next prime
4.
number.
5.
It is 5. Can you divide this number by 5?
No, ma'am.
No. So go for the next prime number. What is next prime number?
7.
7. So we'll check with 7. So 7 2s are 14. 3,
14.
7. 7 5s are 25.
35.
2, 1. 7 3s are 20.
21.
So this goes with 7.
Yes, ma'am.
So 1 7 7. 7 times how much? 253. Correct? So this is how you check the divisibility. Right? And next again, you have to divide 253. Again check with, go with the starting prime number. 253 divided by 2, you can't divide. Correct? Next, go for the next prime number. Which is the next prime number? 3. So 253 divided by 3, can you do? 8s are 24. 1, 13. So with 3 you can't divide. Next prime number 5. 5 4 you
5.
can't divide. Correct?
Yes, ma'am.
Then we check with 7.
No, ma'am, it's not possible. Even it's
7 also it is not possible.
no, ma'am.
We check. 7 3 are 21. So 43 you can't divide by 7. After 7, which is the next prime number?
11.
It's
11.
11. So 253 divided by 11. 11 2s are 22. 3 33. 11 3s are 33. And 0. So it goes with 11. So 11
Yes,
is 1.
ma'am.
Then 23, can you further divide it further? No, it is already 23 is
No.
already a prime number. So you get a 1. So the factors for this is 7 into 11 into. Understood?
Yes, ma'am.
Pawan, understood?
Yes, ma'am.
So you check for each and every prime number. Divide it. Like if you get a reminder 0, then that's a factor. If you don't get a 0, then go for the next prime number. That's how we check the divisibility. Okay?
Okay, ma'am.
Everyone understood?
Yes, ma'am.
Any
Yes,
doubts?
ma'am.
Want me to repeat this again?
No, ma'am.
Sure?
Yes, ma'am.
Ma'am.
Okay, fine. Next, we'll go to the next concept. In the practice session, we'll work on few more questions. Okay? Yes. Next, using this again, a fundamental theorem of arithmetic, we use this again to find the HCF and FCF. HCF. Okay. We are using this concept to find the HCF and LCM of two integers. Right? And we are using this concept in the sense, again, we are using the prime factorization method. Whatever the number you get, those two numbers expressed in terms of prime factors. Okay? And then find the HCF and LCM. That is how we are using this fundamental theorem of arithmetic to find the HCF and LCM. Okay? Understanding?
Ma'am, can you repeat?
Hello?
Ma'am, can you repeat it?
Didn't hear me or you didn't understand?
Ma'am, I didn't understand you.
Okay. For example, I have taken two integers, let's say A and B. Okay, those are the two integers, and you have to find the HCF and LCM for these two integers. Okay, that is the question given. And like, for example, if I give you, directly find the HCF and LCM, you can just factorize them and you find the HCF and LCM, correct? But here, what we are doing
Yes,
is, we learned, as of now, just before we learned fundamental theorem of arithmetic, correct? That is nothing but prime factorization. Like any integer can be expressed as a product of prime numbers, correct? That is the fundamental theory of arithmetic, is it not? We are using that method to find the HCF and LCM. Understood?
Okay, ma'am.
Which is nothing but we are factorizing using prime numbers. Okay, and then find the HCF and LCM. Okay,
Okay, ma'am.
I'll take a simple example. Let's say find HCF and LCM of 6. Okay. First, you will express 6 as a product of prime numbers. Prime numbers means 2, 3 is a 3, 1 is a. Correct? So 6 is nothing but 2 into 3. Next, 20. 2 tens are 20. Then 2 fives are 5 ones are. So the factors for 20 are 2 into 2 into 5. Can you see the factors here, guys? All the factors are only prime numbers. Correct? Understanding? Then
ma'am.
now find the HCF. LCM. How do you find the HCF? Remember? How do you find the HCF?
Common factors.
Take the common factors. The common factors here is 2. The HCF is 2. LCM is, you take the common factors. Along with the common factors, take the remaining factors also. Six.
Video on.
Understood? Any doubts with this? If you remember, if you have attended the foundation class, then you would have remembered how to find the HCF and LCM. Because we have discussed this topic, how to find HCF and LCM in the foundation class. Okay, that's fine. Want me to repeat again?
No,
Any
ma'am.
of you? Pawan,
No, ma'am.
understood?
Yes, ma'am.
You want me to repeat?
No, ma'am.
Arpita, Mohammed,
No, ma'am.
Inchara, Puneet,
Ma'am, I
Shekhar,
just have a doubt.
Ruti, Prajwal. Any doubts?
No.
No, ma'am.
Yes, Pawan, tell me.
Ma'am, we should do 6 and 20 individually, like, ma'am, 2 3s are 6, like that, ma'am. We should not do it like together, like.
You can do it together also, Pawan. But what happens is, if you do it together, you'll be confused like what factors will go for 6 and what factors will go for 20. So that's why I suggest you do it separately. Find the factors of 6 first separately, then find the factors for 20 separately. So that you can avoid confusions and avoid mistakes. That's it. Like you can do it together also, not a problem.
Okay, ma'am.
Any other doubts, guys?
No,
No,
ma'am.
ma'am.
Sure.
Yes, ma'am.
Yes.
Okay.
No.
I'll just give you a question. Try to solve it. Find the HCF and FCF of 96. Using fundamental theorem of arithmetic, which means that you have to use only prime factors, any factors. I want everyone to solve. Rajwal, give me the factors for 96.
3, 2, 2, 2, 2, 2.
Tell me. 2, how much?
Ma'am, 3, that one. I gave it a person 3.
Go with 2 first. Start with
Can I
2
tell?
always. Start with the smallest prime number. Don't directly jump into 3, 5, 7 like that. Start with 2. If you cannot divide a number by 2, then go for 3. If you can't divide it by 3, then go for 5. Go one after the other. Directly go. Don't go for bigger numbers. Yes.
Ma'am, can I tell?
Yes, tell me.
The prime factors are 2 into 2 into 2 into
Wait,
2.
tell me the division thing. 248.
Ma'am, 2 48s are 96, 2 24s are 48, 2 12s are 24, 2 6 are 12, 3 3s are 6, and 3 1s are 3.
Mr. 96 plus factors for 404.
Ma'am, I'm starting it now.
Anyone
Twos
has
are
2. Ma'am, 22101.
twos are 202, ma'am. Then divided by 2 is 101.
101.
101.
That's it.
101
101.
itself is a
One.
prime number. Correct? Yes.
Yes.
So factors for 404 are 2 into 0. Now, we will find the HCF first. HCF, just pick the common factors. 2,
I'm 4.
yes. So, HCF is 4. LCM, we pick the common factors. Along with that, take the remaining factors also. 3, 5 into 3 into 1. If you want, you can multiply and keep the bigger number, or you can just leave it like this. Can you tell me the answer like if anyone has done?
Ma'am, 9696.
So keep our 5 as 32 into 203. That is equal to 9. Done? Guys, any doubts with this question?
No, ma'am.
So next, we have a formula where we can verify this HCF and LCM value. For example, let's say, okay, let me give you the formula first. HCF of any two numbers like HCF and LCM, and the any two numbers are A and B. The relationship between them is the product of HCF and LCM is equal to the product of these two numbers. This is how we verify whether whatever the HCF and LCM they are found is like correct or wrong. Okay, so here you got HCF as the LCM as the biggest number, correct? You have to multiply so much and then find what is LCM. Instead, you can use this formula to find LCM. LCM is equal to A into B divided by the HCF of those two numbers. So A is nothing but 96, B is 404 divided by HCF is 2. Okay. So can you simplify this and tell me? Cancel. 4 ones are 4. 101. Correct? So your answer will be 96967. So instead of multiplying so much, you can just use this formula and find the LCM. You can use this formula to find whether, like, if HCF is given, you can find the LCM, or if LCM is given, you can find the HCF. Okay, and if sometimes what happens in the question, they'll give both HCF and LCM and any one of the number, and you find the other number, find the missing number. So in such situations, you can use this formula. Okay.
Ma'am, can we use this formula in the test?
Yeah, you can. You can use. This formula is mainly to verify whether, like, whatever the answer you have got, HCF and LCM is correct or not. How you verify is,
Ma'am, can we just directly go for this formula, or should we do the LCM?
okay, it depends on the question, Shrikar. If they ask you to find the HCF and LCM using fundamental theorem of arithmetic, then you need to do all these things, like finding the factor, then find HCF and LCM. You have to do all these things. Instead, if they directly give you the question, like there are two numbers so and so, and HCF is given, if you want to find the LCM, then you can use the formula. So read the question carefully and then answer. Okay. Because in the question itself, it will be given, like which method you have to use. If they have mentioned that you have to use fundamental theorem of arithmetic, then you have to do all these things. Okay.
Okay, ma'am.
Yeah. Any other questions? Any other doubts you have got?
No, ma'am.
Sure. Yeah, can we just recall, like we have got another 4 minutes, so this session will get over. So can we just recall whatever we did, and in the next session, the practice session, we will practice a question based on these topics, whatever we did today. So we started with
The long division and the factor tree and the prime factorization.
what's the
Fundamental
topic?
theorem.
Yes, the topic name is fundamental theorem of
Fundamental theorem of arithmetic numbers.
Yes. What is that theorem? Like, how do you do that?
You do the long division and find the factor tree.
Why do you do long division and why do you go for factor tree? What's the main intention there?
Prime factorization.
Yes. Given two numbers or any number, any natural number can be expressed as the product of prime factors. That's nothing but fundamental theorem of arithmetic. Correct? Product expressing any natural number using in the form of product of prime numbers. And then we learned how to find the HCF and LCM using this fundamental theorem. Okay. You have to factorize in such a way that you have to get all the prime factors, then find the HCF and LCM. Okay. And also, we learned a formula which can be used to verify whether whatever the answer you have got is right or wrong, or sometimes you can also use it to find the missing number. The missing number can be either HCF or LCM or any one of the integers out of two. Okay. So these are the things we learned today. Any doubts with us? Whatever we did?
No, ma'am.
Everyone. Pawan,
No,
Inchara,
Ma'am.
Rajwal,
No, ma'am.
Peter, Mohammed,
No.
Arpita, Puneet, Karan, Ruby.
No.
Sure?
No.
Yes, ma'am.
Okay. So you guys can take a break for 5 minutes. Okay? And then come back.
Ma'am, I'm having a doubt in this solving of questions based on Euclid's division lemma.
You would have asked at the very beginning itself, no, Puneet. I asked you like,
Ah.
no, if you have got doubts from previous topic, then you were silent then.
Ma'am, that time a doubt didn't come when I referred the textbook.
Okay, fine. You can ask me in the practice session. Okay? You can ask me in the next session. Fine?
Yes, ma'am.
Okay then. Fine. You guys can take a break and come back after 5 minutes. Okay?